In this video, I want to make an XPS peak fitting for the zinc oxide nanoparticles. I will make a peak fitting for the zinc 2p region, but first I have to open or convert the data. File, convert, and this is our data. So firstly, I want to make a background, and I need to choose a proper background. We have generally used Shirley or Tougaard, but as you know, Shirley doesn't account for energy loss features for the satellites, and we can see the satellites in here. These two are probably our satellites. On the other hand, Tougaard accounts for the energy-dependent inelastic mean free path of electrons, so that I prefer to choose Tougaard in this example. But also, you will see another problem. So create Tougaard. So this is Tougaard background. I'm making little adjustments. And as you see, our Tougaard background intersects with the data itself. So we cannot use this background right now. So this is not a straightforward example as my previous video about the carbon one is speaking, and you can see it on the right corner. In this example, I want to make Tougaard backgrounds. So I will take the one background from here, maybe somewhere here to here, so that I can put a peak or two peaks actually in this sample. Also, I want to make another peak fitting for this peak itself. So I will click again create. So this is our second Tougaard background. As you know, we are actually doing the same thing for the zinc oxide. For instance, if I want to make a peak fitting for the oxygen, I will make the background for the oxygen part separately. So this is the same logic. I'm just making the background separately for each peak. And then I want to show the detail. This is the one peak and this is the second peak. Before adding the components, I have to choose A and B from here. I looked at the literature. So this is our zinc oxide nanoparticles, and the most similar paper is this one. And according to this paper, we can observe zinc OH 2 molecules. So I have to find it here. So if you look at the picture here, we have zinc hydroxide on this sample, and this is also a zinc oxide particle, so that we can also have this kind of features in our data. But if you are careful, maybe this peak fitting is not perfect. Envelope seems very thick, and probably the fitting was not at very high quality. But whatever, I will try to make a similar peak fitting for our data, but I will do that for zinc 2p3 over 2 and zinc 2p1 over 2. So I can close this part. So firstly, I will add the components on peak A. I will click the components and click create. So this is our zinc oxide or zinc 2p. I have to look at the binding energy. Yes, 3 over 2. This is 3 over 2. Zinc 2p 3 over 2. I want to use Gi40. This means that it is a mixture of Gaussian plus Lorentzian. So I have to click enter. If I don't click enter, it does the changes. So this is the first peak. And I want to put another peak so that I'll create another one. And this is for the zinc OH2. Maybe I can write 3 over 2 and click enter. I again want to use GL40. So this is the line shape. And fit the components. So this is pretty wrong. As you see, since this peak should be around here. And I maybe should constrain the region. So I think it shouldn't exceed 1022, and I can write it here. 1022, around here. So click enter and fit the components. So it doesn't work. Full with half maximum is too much. It can be 2. Maybe I should also make the peak fittings for the other region. So I want to choose region B. This is the zinc 2p1 over 2. I can add the components. So create one. I don't know, but because XPS started to make very broad peaks, maybe there are two backgrounds right now, and this is the issue. Again, I want to use GL30 or 40, not 30, 40. And I will add another component. And this is for zinc OH2. And I want to write 1 over 2 here. This is also GL30 or 40. 40, yes. Full width half maximum is right now very high. We can make it a little bit smaller. We should constrain it. So I constrain this peak. I will constrain until 2 for this peak. This is full width half maximum limiting. So I limit that part. I want to also limit this one. Maybe 2.5. Oops, 2.5 should be in here. And this one also can be 2.5. So constrain components to the region. I'll click yes and fit the components. We can look the other region, A. So it is pretty good. And this is the other region, and this is the component B. So as you see, there is a little bit issue here. We couldn't make a peak fitting. And I think this was also the case in this paper. There might be an issue here. Therefore, the envelope is very thick here. But maybe there is also another feature. So these nanoparticles are very complicated features, especially mine. This is not a published sample, therefore I don't want to give more details. But I hope this video was useful for you. And I showed the exportation from the CASA XPS, and you can watch that video if you want to learn it.